Okay, hello everyone. In this video, I talk about chapter 3, section 3.1 on dynamic routing. Okay, so there are three things I would like to talk about in this lesson. The function of dynamic routing protocols, the purpose of dynamic routing protocols, and their uses, where we can use dynamic routing and where we can use static routing. Okay, so dynamic routing protocols have been used since the late 1980s, and one of the first routing protocols was the RIP, the Routing Information Protocol. RIP version 1 was released in 1988, but some of the basic algorithms with the protocol were used on the ARPANET, or the Advanced Research Projects Agency Network, as early as 1969. And as the networks evolved and became more complex, new routing protocols started to emerge in the market. And RIP protocol was updated to RIP version 2 to accommodate growth in the network environment. However, take note that RIP version 2 still does not scale to the larger network implementations of today. It still does not scale. So there was a need for other dynamic routing protocols that could overcome this limitation in RIP version 2. So to address the needs of larger networks, two advanced routing protocols were developed. This was the OSPF, the Open Shortest Path First routing protocol, which is a link state routing protocol, and the intermediate system to intermediate system, ISIS. And Cisco also developed the IGRP, which has now become the EIGRP, which really scales well in larger network implementations, unlike its original IGRP protocol. And additionally, there was the need to connect ISPs, okay, two different internetworks, and provide routing between these internetworks. And that's where the border gateway protocol is now used between internet service providers. Take note here that BGP comes in various different forms again, types again. In CCNA 4, we will look at a BGP protocol known as the eBGP, the external BGP. Okay, so BGP has its place in a network, and it's typically used between service providers. Okay, and it's also used specifically for the larger private clients to exchange routing information, especially when you have multiple areas or autonomous systems made up of areas. That's where BGP can be can be used here. But within the areas themselves, you could have just OSPF running. Okay, you could have only OSPF running. Okay, routing protocols, what's their purpose and what is their function? Before we look at the purpose of routing protocols, what's important to note here is that routing protocols, they also have components that are used to achieve each one of these purposes. Okay, so first of all, there are about four different purposes of dynamic routing protocols. Routing protocols are basically used to facilitate exchange of routing information between routers. A routing protocol is basically just a set of processes, algorithms, and messages, and that are used to exchange routing information and populate the routing table with a routing protocol's choice of best paths. So there'll be a list of paths that are available, multiple paths that are available. The protocol will have to discover these paths, and then over the course of over the course of existence of the network, the dynamic routing protocol has to try and maintain this routing information. And then after it has learned about all of these paths, it will try to use some form of algorithm to choose which path out of all of these paths listed is the best path to the destination network. And it uses algorithms to find the best path if the current path is no longer available. So this brings to mind these three major components or main components of dynamic routing protocols that help it to achieve these four main tasks. Okay, so you can see we have data structures. Okay, these are tables or databases that are kept inside the RAM. For example, the routing table. Okay, routing table is an example of the data structure. Routing table is used to maintain up-to-date information about the routes or paths that the router has learned about. Even remote networks that it has learned about, it will maintain that information in the routing table. And then you have the next component, which is the routing protocol messages. Now this idea about how a router is able to discover remote networks is through the use of routing protocol messages. A router is able to discover its neighbor simply by exchange of messages. So it discovers those neighbor routers through exchanging this routing information and then maintaining accurate information about these networks that it has learned about in its routing table. Now in the event that it has multiple paths to a same destination, how is it possible for it to find the new best path? This is where it uses algorithms. It uses algorithms to facilitate this process of calculating out of all of these multiple routes available, which of these route can become the best path. Okay, so this is known as path determination. For path determination to work, dynamic routing protocols use different algorithms, and it all depends entirely on which particular routing protocol you are using. If you look back at the introductory notes on section 3.1, you would have seen a list of dynamic routing protocols. Two main examples: you have distance vector, EIGRP, and then you have link state, OSPF and ISIS. Distance vector, you have the IGRP and the EIGRP. These are examples of dynamic routing protocols, both distance vector and link state routing protocols. They use different algorithms. They use their own algorithms to facilitate them being able to calculate the best path to take to a particular destination when there are multiple paths available. Before identifying the benefits of dynamic routing protocols, let's consider some of the reasons why you as a network professional would try to determine whether you use static routing or you're going to use dynamic routing. Now, often in most cases, networks do use both static and dynamic routing. Okay, we are not saying here that we entirely remove static routing because there is dynamic routing available. The point here is they have their uses. They have their uses and they have their places in a particular network, and you could end up with a network running both static routing and dynamic routing. So static routing, as an example here, certainly has several advantages that we can see, where it will allow it to be used in a particular network instead of dynamic routing. For example, if you wanted to have a simple routing table, a very simple routing table, you could use static routing. Okay, and this is typically done in a network that's not expected to grow over the next 5 to 6 years. But again, if scaling is going to be one of the things that you will consider in your network, then static routing may not be the right option to use. Okay, so there are several reasons or primary reasons why you would still use or you would still prefer static routing over dynamic routing. As I mentioned earlier, for ease of the routing table, especially in a small network that is not expected to grow in the next 5 to 10 years. Another reason you would use static routing is in a stub network, okay, where you have only one entry and exit point. In the case of this example here, in this diagram, you can see that router 1, we could use static routing here instead of dynamic routing, simply for the reason that there's only one entry and exit point into this network. Okay, that's via router 2. Okay, so exit point to the internet is via router 2. Entry point for other neighbor networks into these networks is also via router 2. So this is where you will configure static routing instead of dynamic routing. Another area where static routing could be used is when you're accessing a single default route, which typically is used to represent a path to any network that does not have a specific match within the routing table of this any particular router. Again, this is pointing back to stub routers or stub networks rather. For instance, internet access. Here we could have entries that will contain only connections to these two networks. Now anything else that is destined for any other networks that is not found in this routing R1 routing table will be forwarded to the internet. Remember when we talked about static routes, they also are default routes. It's an example where we have a gateway of last resort. So if there's no match found in this router 1's routing table, everything will be forwarded to the default route, which so happens to be the quad 0 network 0.0.0.0 with a subnet mask of 0.0.0.0 again. Okay, so here we highlight some of the advantages and disadvantages of static routing. First of all, static routing, right off the bat you can see that it's quite easy to implement in a very small network, and static routes typically stay the same, which makes them fairly easy to troubleshoot. They do not send update messages back and forth, and this means that it places very little overhead or no overhead at all on the network, unlike dynamic routing protocols that place a lot of overhead because of additional information that is added on. Also, when you look at static routing, you can see it's very secure because it does not exchange route advertisements, so it minimizes the security risk attached with exchange of route advertisements. And there is also no routing algorithm used here, so it does not require additional resources like CPU and RAM requirements. But of course there are disadvantages. They are not easy to implement, especially when you start to have the network growing exponentially over the next 5 to 6 years. When your network is going to scale and become larger and larger, the topology is going to be more complex. Static routing will not be a very good option to use, and it's not going to be a practical option to choose, especially when you have a very large network. Configuration complexity is one reason why static routing would not be a preferable option in a more complex network, in a more larger network. And it will require a lot of manual intervention if you're going to reroute traffic. Remember, the routes to destination stays the same. So if there is an event where one of the network goes down, or the devices go down, or the paths go down, then there's no way of the paths being dynamically changed. So you have to manually do that. And these are some of the advantages. So these disadvantages brings to mind the preference of dynamic routing over static routing. So dynamic routing in this case would be the best choice for large networks. And dynamic routing protocols help the network administrator to manage this time-consuming process of configuring and maintaining static routes. Imagine maintaining the static routing configurations for all 7 routers in this network. It's going to be a lot of work, a very tedious task. It's going to take up a lot of time, trying to maintain every single routing table and destination paths in each of the 7 routers. And think about this. What if the company were to grow and then have 4 regions and 28 routers to manage? What happens when a link goes down, in one of these links? How do you ensure that the redundant paths are available? Dynamic routing here is going to be the best choice to use, simply for the reason that you are no longer manually updating the paths here. You just configure the dynamic routing protocol, and it's entirely the job of the dynamic routing protocol to calculate all of this. That's where this whole idea of algorithms come in. Algorithms are basically uh, the mechanism that is there to calculate out of all of these multiple paths which path not path but which path is the best path to choose. And if a primary path failed, you see we have multiple paths available here. If one of these paths were to go down, dynamic routing protocol will use one of its algorithms to recalculate out of all of these multiple paths which path is the next best option to choose from. So these are some of the reasons why dynamic routing would be more preferable over static routing. It's suitable in any topology where multiple routers are required. So you talk about hub and spoke topology, star topology, partial mesh topology, full mesh topology. This is where dynamic routing protocol is going to be very useful. And it's generally independent of the size of the network. It does not have to rely on whether it's a small network, a medium-sized network, or a large enterprise network. It can work on any size. At least the network is consisted of several routers. You would prefer to use dynamic routing protocol. And although there is more to the configuration of dynamic routing protocols, they are much simpler to configure than static routing in larger networks. Okay, so don't think that there'll be more complex protocols involved. Of course, there'll be a few parameters that are involved, but typically the configurations are much simpler once you start to really understand the purpose of the commands that are used in dynamic routing protocols. Again, as you can see here, one of the key disadvantages about well, several of the key disadvantages about dynamic routing protocols is this idea of requiring additional CPU, RAM, as well as bandwidth. And for two main reasons. If through the use of algorithms, these algorithms do a lot of calculations, and that's the reason why it requires additional CPU and RAM. And you know that dynamic routing protocols will carry a lot of overhead, and they will carry a lot of additional information onto the actual data that's going to be carried across the WAN link. This requires more bandwidth. Okay, so you will need to have sufficient bandwidth if you're going to use dynamic routing protocols in your network. Okay, so in this lesson we basically talked about dynamic routing protocols and their purpose and where they can be used, and what are some of the advantages and disadvantages of dynamic routing protocols and compared to static routing protocols. In the next lesson, in the next section, section 3.2, we will talk about routing information protocol, RIP version 2. Okay, don't think that this is rest in peace. Okay, no, this is routing information protocol. It's one of those routing protocols that we're going to look at. In the meantime, after you finish watching this video, please have a look at the section 3.1 quiz on NetAcad. Okay, thank you, and we'll see you in the next lesson.